Babe, wake up. AGI, babe. Babe, it's AGI. Self-modifying, babe. Builds its own agents, babe. It's able to improve on itself and get better scores on the ARC challenge, babe. With 3.5. Researchers have caught up to the classes I launched last year. New paper on the automated design of agentic system. Here's the thing I made a year ago, and here's the code. So if you want to immediately play with it, here's mine. Here's theirs. Let me explain. Agents are AIs that can do stuff. You make plans, choices about what to do, and tools. These are the elements of an agent over here. But this agent was discovered by an AI and not written by a human. So we start with a meta agent. That meta agent generates other agents. Then it builds a tester that tests the performance of the other agents automatically and gives them a utility function. Then it saves those agents in a list of agents. Then it uses the information it learned by developing that agent to make the next agent. We look at and test a whole bunch of different agent architecture. If that's confusing for you, but you're an engineer, you could take my agent engineering class and we'll talk about all of these different architectures and structures. Really, it just means how the AI works inside. So we can think of agents as a search space in this way. The best one on the ARC challenge, which I still think is BS, was this one. This was the agent that did the best on the ARC prize. And then here's what that search space kind of looks like. Okay, so let's zoom into this. So we generated high-level strategies and we got to a certain level. Then we used multiple chains of thought. This is something that the AI decided to do on its own. This is really like a timeline of what it did. Then it adds dynamic memory. Then it scales up the previous idea. And eventually the best agent came out. I'll remind you, we're also doing this live for free on Fridays, 2 p.m. Pacific, 5 p.m. Eastern. And we're live coding a self-improving agent. It doesn't redesign itself, but maybe we'll add that now that this paper's out. Anyway, we went from a 6 to a 13 by doing this on the ARC prize, so here's some of the other benchmarks. Looks like they were able to improve on all benchmarks, basically, by having the agent design itself. It's not that language models are AGI. It's that agents are AGI, and language models are part of agents. So I got it to run. It beats the MGSM. I'm working on the MMLU, but it takes a long time to generate them, and so it keeps erroring out, but we'll get there. I'm just running them on LM Studio with Metalllama 3.1 Instruct, 8B quantized down to 8 bits. It just generates a bunch of code, and it runs itself through debug steps. So there was a problem in the code, and now it's regenerating that same code, given the error. It takes a really long time with 3.1B. Basically, you have an agent that designs other agents, and so they just have a bunch of functions called forward, which are steps, kind of like in a machine learning algorithm. But instead of a softmax output, we have agents as the output, or elements of the task. It starts with these templates, like the chain of thought agent, that it's just a function that does a chain of thought approach. Here's chain of thought with self-consistency. Here's chain of thought with self-reflection. Here's large language models debating with each other. So these are all just a function called forward where some stuff with large language models happens inside. The thing is the meta agent, which then makes other agents. It takes those examples and just tweaks them and adds some other stuff. And we test it on the tasks. This is why benchmarks are important. The MMLU is not very good, but it's one of the best ones we have. ARC is not good, but it's one of the best ones we have. And then its performance on the tasks are added to the archive so that the meta agent can look in the agent archive for ones that were good on specific types of tasks and can compose a new agent. So it's able to do stuff like write these other different agents out of the other agents. It searched and designed these agents itself. A human did not design these 3 agents. It's not perfect on the MMLU, but I think the limits that the authors ran into was literally just the cost on the API. Searching all possible agents, it's a large space, so have we found the best agents that exist? No, but we've figured out that we can get improvement on human designs by just letting the AI design itself. So let's do that to the robot today. See you soon. Also, prompt engineering, the next cohort, the one that's intended for Europe, starts next week, so you better sign up for using large language models. See ya. I told you that the singularity was here. Anyway, if you want to be in on the third class that teaches this stuff, it's available.